So I'm just going to share a little bit of our story in San Francisco, kind of talk about, I'm not sure where here, there's the remote. This might come in handy. Talk a little bit about the why and the what of our zero waste policy, and then focus in on our key programs and sort of what kind of results we've gotten. So let's take off. So San Francisco, everybody's probably heard of it, in California. I work for the city of San Francisco, and we're focused on the actual city county itself. We actually have 850,000 people, and people think, oh, that's not that many, not millions. But actually during the daytime increases by half, as we have so many people coming into work. We've got over 16 million tourists that visit us a year. And we're the second most dense city in the country, with a lot of people living, two-thirds of the people living in apartment buildings, and 8,700 high-rise buildings, and a very multilingual, multicultural population. So very dense, and also quite multicultural. All that red are people from Asian countries. The second most spoken language is Cantonese, then followed by Spanish, and then Filipino and Vietnamese and Russian. So we have quite a mix, quite an international population. And we have a long history of resource recovery in San Francisco that we kind of take pride in. And in recent years, a big driver in California was the state law, which set a mandate of 50% diversion by the year 2000. And that actually helped California go. It triggered the public and private investment that is really critical in the public policy that drives that. So we went from about 10% diversion to about 60% in California, and we've been able to fortunately go a little beyond that in San Francisco. But when we achieved that, our 50% diversion just around 2000, and the state hadn't set a higher goal, we were thinking, well, 50% is not enough, of course. And I think that's always important to remember why we recycle. It's not so much about saving landfill space. That can be immediate concern. But it's this inherent unsustainability that is resulting in a lot of impact. And we came up with this concept of tip of the iceberg, which was actually grab the attention of policymakers in setting our policy, which is that for every, say, kilo or ton that we are dealing with at the municipal level, when we dispose of that, when we turn around and buy those products to replace the ones we disposed, those products created over 70 times that amount of waste upstream in that resource extraction manufacturing process. So when we talk about recycling a ton, we're not saving a ton of resources, we're saving over 70 times that. And this is about saving resources that if we're extracting them, they're tremendously damaging to the environment, of course. We have a lot of impact on the environment. One of the things that we're hearing more about is how a lot of the plastics are getting into the ocean, 6 times the amount of phytoplankton in the gyres, and there are like 5 of them worldwide. And of course, there's a strong connection to climate. All the energy that's used to produce our products is resulting in emissions that have an impact on the climate. And of course, if we're putting organics into the landfill, creating methane, there's an impact there. And actually, this is sorry about jumping around. This is an interesting frame. When we usually think about climate impact, we're usually thinking about that it's the energy that we're using in our vehicles, in our power plants, in our homes and buildings, and that's what we have to reduce. But if you think about the material life cycle, this linear system is creating a huge impact. And here is the US EPA basically put this together saying the provision of goods is about 30%, the provision of food is about 13%. So 42% of all the greenhouse gases are actually due to the product life cycle. So that if we move essentially to reduce that, we're going to have a huge benefit. And then a whole other piece that connects with climate is the need to preserve soils. And soils are becoming very depleted. The Year of the Soil internationally is trying to highlight the desperate need, the problem of loss of organic matter and erosion, and with droughts or floods damaging soils. And actually the health of the soil directly relates not only to the health of our food, but also to the health of the climate. And then, of course, there's the producing jobs. And recycling produces, on average, 10 times more jobs. Composting, 4 to 6 times if you include using compost. Reuse, repair can be up to 100 times. So all this is all about how we need to move from this unsustainable linear economy to a circular economy. And there are many different ways of cycling materials. If it's reuse, it's closer in. Recycling, you've got technical nutrients. There's one way of thinking about it, biological nutrients. So I just like this framework about why we're pursuing zero waste. So based on that, we went through a process in San Francisco about 13 years ago where we had a policy commission for the environment who was an international rainforest activist. Randy Hayes started that effort, and basically got this very audacious goal. Going for zero waste is an extremely ambitious aspirational goal, but we ended up having a board of supervisors and mayor that wanted to be the first. So we were the first in the US to set a goal actually with a date, and that date was 2020. Now, when I was writing the policy, I was thinking, well, maybe sometime way out in the future. And they were saying, no, you have to have a date. And then, what about 2030? No, that's too far, 2025. So 2020 was just done based on kind of a political basis of having it something that's close enough to go for. But it wasn't like we had a detailed plan on how we're getting there, and we're still working to figure that out. So it's really about zero waste to landfill, of course. We also say zero waste to incineration in the sense of that we're just burning mixed material, perpetuating that linear economy. There could be we learned about just now some high temperature processes to break materials apart can certainly have a role. Promoting the highest and best use is our key principle. When we think about just not keeping material at the landfill, how can we recover the best reusable material we can, the best value of those resources? And part of this is not just about producing valuable programs, but getting everybody involved, taking responsibility, consumers and producers. So an example of our highest and best principle is what we call the sort of, I have here the hierarchy. I know you can't really read it, but if you look at just organics food, reducing food waste, feeding people, feeding animals, feeding microbes. So we actually provided grants to our food bank with a refrigerator driver and truck that recovers a lot of the edible food and redistributes it. Food going to animal feed, food processing waste, sorted produce, grease, fats, oils, and grease, using to make products like biodiesel rendering, and even then on-site composting before large-scale composting. So we did all those things before we implemented our 3-stream program, which we started to develop in the late 90s and then started to roll out in 2000. So that's what I want to focus most of my next bit of time here, which is that our focus is, I've seen this a lot, we have it here in many communities, a 3-stream program, and we go with blue, green, and black versus the equivalent, I guess, here would be yellow, green, and red. And essentially, we work in close partnership. So the city, we help kind of create the policy and create the programs with our partner. We have a partner, which is the company, Recology Companies. We have a unique situation in San Francisco where we have a long-term exclusive permit situation that they have. So we don't have to go out to bid and are limited by a 10-year contract. We actually have a longer-term bid. They function like a utility, and we regulate them through the rate-setting process. And we find that works quite well. A lot of what we do can be done in a contract basis, but there's more constraints there. So we've basically have created programs that are based on trying to create as much convenience and consistency to capture as much material. We have all recyclables going in to our blue bin. So like here, it's a fully commingled recycling program. And we basically capture a lot of the same materials as you have here going in there. This is our recycling facility, and it's out at a pier in southeast San Francisco. You can see there's a solar on the roof. And essentially, this is just a standard MRF with a pre-sort. This was built back in 2002, so it is not a state-of-the-art anymore. But we do disc screens, star screens that separate the fiber from the containers, and then sort about 16 different grades of material. And we have local markets for glass in the Bay Area, cardboard in Southern California, and certain types of plastics. But a lot of the paper and a good portion of the plastics, as a commodity, it's been going to China and other Asian countries. We actually have one of the biggest ports across the bay in Oakland, and we have so much coming in from China and those countries that we have empty containers going back, so it's sort of like a cheap backhaul. So that's an advantage where we are, maybe a disadvantage in that it's harder to develop local industry with those economic forces just pulling material to Asia. And then we have a composting container where we collect all food scraps, and we collect plant debris mixed with that, garden waste, and food soil paper. And that is both the blue and the green are collected in trucks that are side loading, kind of easier to look at the material. Some of these trucks have smaller wheelbase. It's good for the tight spaces in San Francisco. And these are done on a weekly basis for all three streams. Once we collect the organics, it goes through a transfer station, and we don't have space in San Francisco for our composting facilities. So our ecology partner brings it out to two composting facilities in the region, in the agricultural area. And this is an example of one of them where they've evolved the technology over the years. They were actually using a plastic bag system, ag bag system, when they started with food composting. But they found they didn't have the level of control they wanted. And the challenge they've had is they've bring a lot of food in from San Francisco. Our material is about 3/4 food. And then they mix it with some garden material from other areas, but it's still about half. They're doing half food and half garden trimming. So that level presents some challenges, and they've evolved now to do an aerated pile that is used. Well, I'll explain that in a minute. Of course, when it comes in, they just basically do a slow speed shred and a screen and a sort, and that then is the opportunity to pull out the biggest contaminant, which is plastic. And then they basically do a mix of 1-to-1, and they then put these piles on top of these aerated pipes that can be extracted when they have to remove the pile out. And that is on forced aeration for 10 days in this pile. Then they make a new pile for another 10 days, and they do that 3 times. So 30 days of forced aeration. But what they've done is they had been using a reusable plastic cover, but they weren't able to get quite enough aeration. So they layer it with a screened overs. So they screen it. They have about between 8 and 30 millimeters of overs that they put on top as a natural biofilter, and that works well. They pull the air through the ductwork into about a 2-meter biofilter, and that scrubs out 95% of the volatile organics and methane and odor compounds. And here's the 3-way screening that they do, less than 8 millimeters, 30 and over 30. And then they go into turn windrows for about 30 days and slowing that down during curing. So a basic composting process, outdoor, it's cheap. Whoa, I wasn't even touching that. Sorry about that. You get a rogue PowerPoint on me here. It's eager to go forward. Now I'm trying to go backwards, because this is some really great stuff that I want to talk about here. Okay, so the biggest market, once it's used, it's approved for organic use by organic growers. They do a lot of blending. We've worked with soil scientists that work with the growers, and they figure out what is the best recipe for use in the ground, so that, because there is a cost for farmers to apply this, they will then come up with this recipe, mixing in things like gypsum and sawdust, to help balance the pH and lime and so forth. And then they, apply that, and they'll apply that typically, once a year, maybe twice a year. So we basically have landscaping use, but the primary use is produce farms and vineyards, over 200 vineyards in Napa, Sonoma County for this facility, and then fruit and nut orchards. One facility is more in the fruit and nut orchard area, and the other is more in the vineyard area. But in both cases, the key thing here is that most of the compost is used for laying out between the rows, whether they're vineyards or fruit and nut orchards, for growing cover crops. And so this is a picture that I wanted you to take a look at. So look in the foreground, you can see the robust growth of that cover crop, in this case mostly mustard. It's about the height of the grapevines. Now look in the back and it's pretty flat. Well, same time of year, the foreground has compost, the background does not. We get a dramatic difference. Look at that, it's like this very healthy, natural pasture with all sorts of plants. And this mustard plant you see being hauled here, as the plant gets bigger, the bigger the plant gets above ground, the deeper the roots go below ground. And what that does is as the plant grows, it's pulling out, of course, the carbon out of the atmosphere, and it's bringing that carbon down into the roots and exuding that carbon into the ground. And the deeper the roots are, the longer that carbon stays there. So this is a very powerful mechanism of pumping carbon out of the atmosphere and depositing it into the ground. And this is sort of a very simplistic way of looking at it. And I just emphasize this because this is one of the most important messages that I think not everybody appreciates, is that the incredible power of compost to produce more plant growth and change the dynamics of a soil system where you have a lot more carbon being pulled out of the atmosphere and being brought into the deep soil. So you've got carbon being exuded by the plant roots into that soil being stored. And that is something that we saw in the case of vineyards, a difference of traditional till agriculture releasing carbon. It's a carbon as you till the soil, and if you're depleting the soil without adding organic matter, you're basically releasing that carbon into the atmosphere. If you switch to using compost, and especially no-till farming, like cover cropping, then you're actually pulling a net. And so you go from, say, releasing 3,000 pounds, or say a ton of carbon being released, to pulling in several tons of carbon in the same land. So here that we did, it was an interesting demonstration on rangeland where we had detailed monitoring going on. They applied it in year one, only half an inch. So what is that? 12 mil, thank you. I had the conversion on some of these, but not that one. So we basically applied 12 mil of compost one time on this rangeland. And then you basically saw after that they monitored what they did. They monitored before and after, and they monitored these 2 hectare plots that are outlined above. And what they noticed that the cows really appreciated where the compost had been. And they saw that there was a significant amount of additional growth, 40 to 70% additional growth of the foliage. And water retention was improved significantly by at least 15%. And then after year one, they measured beyond the compost add an additional ton of carbon in the soil at a depth where it's going to stay there for 30 to 100 plus years. And then in year two, where they didn't add any more compost, but just 2 years after the application of compost, there was an additional ton of carbon. And then in year three, again, only after one time application of compost, there was another additional ton. And then now they're in year 7, and they're modeling this out, and they really believe that can be just continue to go on for at least 30, if not 100 years. So you really have a very powerful mechanism. And I really emphasize this because I know there's a lot of rangeland all over the world, but especially in Australia. What I read was 75% of Australia's rangeland. Now I recognize that a lot of that, as we look at Australia there, is desert, but there are opportunities to even take lands that are completely depleted or desert-like and add compost and get some of the same benefit. But particularly where you're having grazing land, grasslands, you're raising cattle and different livestock, you have the dynamics of being able to really multiply the benefits of compost in pulling carbon out of the atmosphere and improving the whole system dramatically. So this is something that we've been very excited about, and we like the story of just the organics and nutrient loop, where we have farmers that are producing really healthy organic produce and wines that are bringing it back into the city, and then the farmers are saying to San Francisco, you know, we're feeding you food, you know, feed us your organics. And so we have that nice reciprocal relationship. And then finally, we have the third stream, which is we call our trash stream, and something that is not recyclable or compostable. And the idea is that over time, there are fewer and fewer items. And in fact, if you look at that, a lot of you already are collecting the aseptic Tetra Pak products. We know there are 2 or 3 or a handful of mills worldwide that can actually recycle all that. So it's a growing market, and it is something that we'll be pulling out. It's just not economical for us to do that quite yet. Plastic film can be recycled, but it's not compatible with the recycling system, which is why we all try to keep that out of our recycling bins, because it messes up those disc screens. But that is material that can be brought back to our supermarkets and recycled. And even chip bags, there's companies like Tetra Pak, TerraCycle that are recycling those. So, and then I was at a facility, and we're doing this as well, where I saw that they were recycling the polystyrene foam. So really, you're only left with very few things that can't be recycled. There are things that are much more challenging, so it is a feasibility. But I think as time goes on, we'll be able to reduce that. And that's sort of what gives me hope of being able to continue to progress towards zero waste. So the bottom line is we have a 3-stream system. It's a weekly collection from all our households. We have 150,000 single-family households. We have a lot of 8,700 apartment buildings. And essentially, when we roll this program out, we give out the kitchen pail. We give out a sample set of compostable bags. We allow third-party certified compostable bags that are labeled properly in green. But we say that you can use newspaper, paper bags, cartons to collect it. And on the commercial side, we have a wide variety of bins and containers, frequency up to daily for restaurants. And essentially, we start in the back of the house. San Francisco is a food mecca. We have 5,000 food establishments in the city. And we have such a robust commercial sector and so much food that the large majority, 3/4 of our organics, is really coming from the commercial sector. Front of the house, back of the house, front of the house. Front of the house is a lot more challenging, but we believe ultimately it's an important message for the people who are customers to see that this is stuff that can be recycled. It helps stores, restaurants to reconfigure what they're doing, think about it differently. Let's simplify it. Everything that's paper and food can be composted, maybe all the plastics recycled. Or maybe we just use all compostable foodware, including compostable plastics, and just have a composting container. I've seen that. And try to reduce what goes to the landfill. Here you have an example of signage. There's custom signage here. Signage where it's 3-dimensional. I don't know if you can see that so much in there, but these are actual pieces. And you see how most of this in this hospital is compostable. So proportionally, it's set up to capture most of the compostables. Office buildings, if you just do a good recycling program, you'll see most of what's left is compostable. If you get all the wet compostables out of an office building, most of what's left, of course, is recyclable. Very little trash. We have office buildings, many that are diverting 80-90%. And then in the restrooms, all those paper towels could possibly be recycled, but a lot of times they're soiled and the fibers are short. It's actually better for composting. So we just say, we'll just take all of that for composting. And you only need to have one container there. Maybe you have in the stalls, containers for sanitary napkins, but basically just keep it clean, easy to convert all that. Special events used to be one of the hardest areas to get recycling and composting, and now has been very successful with working with food vendors to use compostable wares. Compostable plastics can play a role there. And then the key thing is just being able to have a good setup with good signage, color coding, and the best is when you've got people monitoring to help focus. Some people are really distracted, they're drinking, they just see a hole and they just throw something, whatever they have. But when you do back of the house sorting, and now we have all these businesses that provide that service because these establishments can save a lot of money, we're seeing 80, 90 plus virtually zero waste results out of these businesses, out of these events. And then we have special collections, things like textiles has been a real challenge. It's one of the largest percents of material that are still left. And so all of this is revolving around how do we get people to participate effectively. We start with the kids in the schools with a lot of programs. They have a whole education, food to flowers, and a mascot. We've learned to use, because of all our languages, mostly pictures. And I see that that's pretty common around the world now. But people don't want to read, they just want to be clued in. And going color coding as well. We have a lot of campaigns that we've worked on emphasizing that. Things like bus shelters, themes around protecting our families, protecting future generations and the climate, competing neighborhoods. Chinese, we just flip the food and you produce more food. A a lot of just clever ways, emphasizing all the benefits of composting, and even putting the pictures on the trucks. But the key, I would say the key success that we've had and the most effective way to reach people is to talk to them. And it's the face-to-face communication. So we have a whole job training program, pulling people from different neighborhoods, often from economically disadvantaged backgrounds, training them in our program and getting them out there to talk to people. So they're out there on an ongoing basis. We've got like a dozen people who are out there every day, either talking to residences or talking to businesses. And this all flows into how we roll the programs out and providing assistance, especially to commercial city government, where we do audits and presentations. Multilingual training is key to that. Working with custodial staff, restaurant staff, setting up efficient sorting, customized signage. Just want to touch on, there is incentives because everybody pays for their service based on the volume, and we actually then discount if the percent recycling they have if you're a commercial establishment. So this funds the whole system like a utility. Is really important. I want to just touch on policy. As I mentioned, mandatory was in the title. One of the most effective policies we've done is mandating participation. And essentially what that is mandating that everybody participate. Everybody has to separate the compostables, recyclables, not just single family, but multifamily, not just food establishments, but all businesses everywhere throughout the city. And when we did this, we passed this back in 2009, we had kind of leveled off our participation, and we were finding a lot of the multi-tenant properties, residential, commercial, the property managers were just not willing to implement it. And so the tenants didn't have that option. So this was a way to kind of push it, and we've been effective in getting everybody on, and we focused primarily on getting everybody to have the service, and now we're going back and we're looking at how they're doing, and because we're auditing their trash bins on a periodic basis, spot checks, and they kind of are on notice. We've actually had some brass, the garbage police are going to come after you. Well, that's good, you know. Got to want them to be a little scared. We follow up with them, giving direct feedback, warnings, and then ultimately fines if needed, but we haven't had to use that much. But the impact has been huge. This is our increase in multifamily composting. It just jumped once we had mandatory. The word got out there, and then we've gone to get everybody on board. And the same thing with commercial. We were kind of leveled out, and now we've jumped up. We have 16,000 commercial accounts representing like 90,000 businesses in the city. And the tonnage, you can see it jumped up and it's kept on increasing. So we're 650 to 700 tons a day of compostables. And 99% plus, virtually everybody now throughout the city has the service. And so now our effort is just to get everybody to participate better. We also require construction demolition debris recycling. It's a whole different type of system because it's an open market. But you have to be registered if you haul the material, and you have to take it to an approved sorting facility. And then finally, we've done other things like banning foodware, expanded styrofoam, single-use plastic bags. We've banned at stores, and then expand that to restaurants, and then even bottled water in city departments. So how are we doing? Well, we've actually achieved 80% diversion, but that's not good enough. We reduced our disposal by more than half, but there's a little thing that's going up there, and I'm admitting that with the incredibly growing economy right now, our population is growing rapidly, we have lots of construction, we have all the Silicon Tech young people wanting to move into the city. We've got a challenge where our disposal started to go up a little bit, and that just means that we've got to enforce mandatory a little bit better, and we still have a lot of organics and recyclables in our trash stream. And I believe that if you have a residual stream, there's the advantage of that is you can have a cleaner recycling and composting stream, important for highest and best use, but you're always going to get a certain amount of the good stuff in the trash stream, right? And so what we need to do then is to be able to recover that. We try to prioritize source separation, but we need to recover the good stuff in the black. And so when we look into the future, one of the ways we're going to encourage better source separation is we're going to go to smaller trash bins and less than weekly collection. So I applaud communities like Coffs Harbour that have been doing that, fortnightly collection of the residual. It's just taking us a little bit longer to go that way. We've got some politics to deal with, but we're piloting that now. in about 10 areas of the city, and it's getting great results. And the other thing is that we need to then recover the material from the black bin, and this is building a future we call zero waste facility. We're in that process now. We're looking at different technologies, and one of the reasons I was eager to come out to Australia is you guys have been a leader, particularly in New South Wales, with a lot of your alternative waste treatment technologies to recover material from the residual. And I'm really interested to see, how well that's going and what are the best technologies. And one of the things that we want to do, and we're building anaerobic digestion facilities. We've been doing that for a number of years with the regional wastewater treatment plant. But we figured that we are already collecting enough food that if we digest that, we can run all our trucks that collect all these materials on food biogas that's now considered a carbon negative fuel in California. And then if we take the organics out of the black bin, we'd be able to do even more. And so anaerobic digestion and fueling future fleets with that gas is part of our future strategy. And then very finally, is my last slide, and I know it's time to wrap up. I just want to emphasize again the importance of zero waste strategies and all that we're doing together here towards the climate. This is our new climate strategy. We've been one of the most ambitious cities in the US for reducing our climate emissions, and we now call it our 0, 50, 100 roots goal, 0 for zero waste, 50 for 50% sustainable transportation. And actually, we're going to go way beyond that because we're basically there. And then 100% renewable electricity. And you know what the hardest one is it is the zero waste. It's going to, but we just need to keep striving there. And then that relates back to the roots. What the roots is about planting trees and returning organics to the soil to pull carbon out of the atmosphere, because it's not enough to reduce emissions. We're already at 400 parts per million. We can just turn off all the emissions, and that's going to stay there for a long time. We've got to pull that carbon out of the atmosphere. And using compost to further facilitate the wonders of nature with photosynthesis to pull that carbon out of the atmosphere and store it in the ground and build healthy soils is the key for that. And that's why the work that so many of you are doing is so important. So I just want to finally emphasize that connection to save our planet by building healthy soil. And thank you very much.
Thanks very much, Jack. And once again, in the interest of time, Jack's here for the